All right, so for number 1, we have these pies, all right, or these fractions. It says Miguel drew the following diagram to represent his math problem. If we're talking about a dividend, a divisor, and a quotient, what math is Miguel doing in this math problem? What operation? We're dividing because we have a dividend, a divisor, and a quotient. So we know we're dividing. Are y'all okay with that? All right, the way division works is this part is divided by the next part, and that gives me the answer, which is labeled as the quotient. So let's kind of investigate what's happening here. All right, we can say here, and I'm going to call these pies. Are y'all okay with that? Like this is a pie. How many pieces of the pie are in the first part? 2 pieces, right? So he has 2 out of the 3, which would be 2/3. Very good. So we have 2 pieces of pie. Are y'all okay with that? Out of how many? 3. So that would create a fraction. I'm dividing that by 1 piece of pie out of 3. So that would be my 2/3 divided by 1/3. All right, so what's happening, and this is what I told my other class to think about. Think about these kind of look like blueberries, right? So I want to put blueberries into these 2 pieces of pie. This is how many blueberries I have. How many times can I put this amount of blueberries into these 2 pieces of pie? How many times can that happen? How many times will this amount of blueberries go into these 2 pieces of pie? Twice, right? It can go in that first piece, and there we can see the pie with the blueberry. Y'all see it? And it can also go into this second piece. There's my other pie with my blueberry. All right? So I had 2/3 divided by 1/3. How many times did it go in there? 2 whole times. Do y'all agree with that? Are there any questions on what I just said? Make sure we kind of said it out loud. Make sure you pick the answer that says what we just went through. We have our 2/3 divided by 1/3, and how many times did it go in there? How many pieces got blueberries? 2 of them. 2 entire pieces. Do y'all agree with that? All right. Dividing fractions can be very confusing because normally when I divide, what happens to my number? It gets smaller. Is that what happened here? I had 2/3 divided by 1/3. It gave me a bigger number. It gave me 2. It gave me a whole. So did my number get smaller here? No. So all that dividing makes things smaller, multiplying makes things bigger. That goes out the window because fractions are weird. Hey, that's okay. We're gonna work through it. We're gonna deal with the weird fractions, and it's gonna be fun. Maybe. All right. Questions? We're good on number 1. I'm moving on. All right. Number 2. Make sure you selected the correct answer on number 1. Number 2, it says, Stephen is teaching his younger brother to divide using long division. His brother is solving this problem. So here's the problem. It wants to know which of the following explains whether Stephen is teaching his brother correctly. So we got to decide, is Stephen doing this correct? So I'm just going to start dividing like I normally would, following along with the work. So I'm going to say 12 will go into 1. How many times can 12 go into 1? 0. What did he write? 1. Can I put a 1 there? No. So guys, we know that automatically is wrong. So is Stephen correct? No, we know he's wrong. Where should he have put that 1? On top of that 2, in the hundredths place. So 12 will go into 12 how many times? 1. Alright, so that would make it correct. Now we just need to pick the answer choice that explains that. So we put the 1 in the wrong location. It should have been over the hundreds instead of the thousands. Are y'all okay with that? Noah? Which is what we just said, right? It goes over the hundreds? But does that say it goes over the hundreds? Does C say it goes over the 100s? Nope, then that's probably not the correct answer. Okay? So make sure you pick the one that says the 1 is in the incorrect place. Alright? Because we're not dividing 112 by 12. We're saying 12 will go into 12. So make sure you choose the correct answer choice that says we've got that 1 in the incorrect place value. Okay? Alright, are there any questions about number 2? Alright, tomorrow we will worry about 3 and 4. Alright, but today I'm going to pass out our notes. So I'm going to pause my recording so I can pass out the notes. Alright, make sure that you put your math workshop away into your math workshop section, please. And we're going to look at our notes for today. right, the last test we had on fractions was adding and subtracting. All right, we also had simplifying and all of that stuff. But the operations that we did on the last test were adding and subtracting. Do y'all agree? Okay, adding and subtracting went together. Now we're going to do multiplying this week. Next week I said we're going to do dividing. And our next test will be only on multiplying and dividing fractions. Can anyone think of why I would do adding and subtracting together and then separately do multiplying and dividing? Why would I put those separate? Why would adding and subtracting go together and then multiplying and dividing go together? Yes, Peyton? So it won't be so long. It helps to break it up. But why would I group those two? Why didn't I do like adding and dividing and subtracting and multiplying? Why would I put adding and subtracting together and multiplying and dividing together? Why would that matter? Jakaria? Okay, so adding and subtracting is easier, possibly. It is with whole numbers. With fractions, you're fixing to be like, ooh, why don't we just multiply? Because it's way easier. Peyton?
Because there are different sections of the math.
Okay, so they are different sections of math. Why would it be so important that adding and subtracting stay together? Why would that matter? What is special about the relationship between adding and subtracting? Jeremy?
The numerators have to be.
Okay, so they both have the same rule. For adding and subtracting, my denominator has to be the same on both of them. All right? The reason that they have to have the same rule is because they are related to each other. Does anyone know how adding and subtracting are related to each other? Like how they compare to each other? Not multiplying, adding and subtracting. How are they related to each other? How are adding and subtracting related to each other? Peyton? They have the same rules. They have the same rules because they're related, but what is the relationship between them? Not the rules, what is the relationship? What is 2 plus 3? 5, okay. If I take 5 and I subtract 2, what's that going to give me? So what are they? So what is that relationship that we just kind of did out loud? What could they be considered? Adding, subtracting are... They have the same numbers involved. They use the same numbers if I'm doing a problem like that. And adding and subtracting are... Peyton? Noah? Opposite! Opposite! That's it! Adding and subtracting are opposites. Do you agree? Adding is the opposite of subtracting. Subtracting is the opposite of adding. Yeah. So, because adding and subtracting are opposites of each other, because they use the same numbers, they have the same rules. Okay. Multiplying and dividing, are they related to each other in any way? What's 2 times 3? 6. What's 6 divided by 2? 3. Are those related to each other? Yeah, they are opposites, okay? So, I know I'm kind of reaching around the world for this, okay? But the whole point is adding and subtracting are opposites, so they have the same rules. Multiplying and dividing are opposites, so they're going to have the same rules, okay? Is multiplying and dividing going to be the same as adding and subtracting? No. Is multiplying related to subtraction? No. So we have to have a different set of rules. Are y'all okay with that? Okay, so we are going to have completely different rules. So do I have to have the same bottom number anymore? No! Guys, my life is about to get so easy. All right, here you go. Here's our rule for multiplying. Straight across. There's your rule. Just go straight across. So if I look at number 1, what's 8 times 1? 8. And then on the bottom, what's 9 times 3? Ta-da! Will that simplify? We always want to see if it'll simplify. No. 8 and 27 will not simplify. Okay. So I need you to pause, okay? Because I don't want us to get too carried away. All right? But all we're doing is going straight across. Which means every single multiplication problem, I could just multiply straight across. I can get my answer, and then I can simplify it. Now here's the problem. When I multiply, my numbers can get really big, really, really fast. And the bigger the number, the harder math. Do y'all agree with that? Like if it's a big number, that means it's going to be hard for me to simplify, especially. Okay, so I want to show you a kind of cool trick, all right, on number 2. This only works when I multiply. So please, if you have worked number 2, slow your roll, because I'm going to show you an easy way to do it. I'm going to show you an easy way, okay? All right. For number 2, we are multiplying here, which is the opposite of dividing, because they have a relationship together. Any numbers on the top can divide with any numbers on the bottom. So just a reminder, if I had the fraction 8 over 36, what do I do in order to simplify that? If I have a fraction 8 over 36, what do I do to simplify that? Jeremy? Okay, what would that be? And what do I do with the 4? I divide them by 4. All right, again, multiplication is the opposite of what? Dividing. So anything on the top can be divided as long as I can divide a number on the bottom by the same thing. So if I look at 6 and 14, 14 is on the top, 6 is on the bottom. They're opposites, right? Top is opposite of the bottom. The opposite of multiplying is dividing, right? So I want you to think about dividing. What number could I divide into 14 and into 6? Noah? 2. Y'all agree 2 will go into both of those? Okay, so we're going to do that. 14 divided by, and you can write it down or not, 14 divided by 2 is? 7. So I'm going to mark that out and make it a 7. 6 divided by 2 is? 3. So I'm going to mark that out and make it a 3. Already my math is easier. Now instead of on the top it's saying 5 times 14, now it says 5 times 7. That already got easier, didn't it? Okay, let's see if we can make this any easier. Do y'all see anything else on the top and on the bottom? Let's try raising your hand so I can hear you. Anything else on the top and the bottom that can simplify? Mary, what?
5 and 25.
What number can go into 5 and into 25? 5. So I'm going to do 5 divided by 5 is? 1. 25 divided by 5 is? 5. Okay, do y'all see anything else that can simplify here? So now I can multiply. Now guys, I don't know about y'all, but 5 times 14 is a lot harder than now. What does it say? 1 times?
7.
What's 1 times 7?
5.
7. Woo, that made it easier. And this way, guys, did I have to simplify any crazy giant numbers? No. We don't like simplifying big numbers. I've seen y'all do it on the test. Y'all don't like it. I got it. Okay? So let's look at the bottom. 3 times 5 gives me? 15. Now, at the end of the problem, I still want to check. Can I simplify that? No. And the reason is because I simplified everything in the problem. If I missed something, guess what? My answer would simplify. Does that mean you have to go back and redo the problem? No, just simplify your answer. That's fine. All right, but if we did everything correctly, then we're going to get an answer that will not simplify, and we'll be done with the problem. Jeremy?
So to divide, you have to go across, or the numbers have to be across?
Okay, that's a great question. It does not always have to be going diagonal. The only rule is you can only simplify top with bottom. They have to be on opposite. I can't do top and top. I can't do bottom and bottom. They have to be opposite. All right, that's a really good question. So I'll give you kind of an example. All right, so let's kind of write, here's a little example, an extra example for us. Let's say I have 9 over 15 times 2 over 13, sure. All right. All right, do y'all see anything here that will simplify?
Yes.
All right. Jeremy, thank you for raising your hand. What do you see that will simplify? The 9 and the 15. Can 9 and 13? No. Can 2 and 15? No. But 9 and 15 can. As long as it's on the top and the other number is on the bottom, I can do that. So what would I divide those by, Jeremy? By 3. So I do 9 divided by 3 is? 3. 15 divided by 3 is? 5. Okay, can 3 and 5 simplify anymore? 3 and 13, 5 and 2, 2 and 13. Nothing else can. So I'm going to multiply now. 3 times 2 is 6, and 5 times 13 is going to be 65. And that would be my answer there. Okay. All right. Let's look at number 3. Now, number 3 is different because it has a whole number. All right. Now, when we were adding and subtracting, you could borrow to make an extra fraction. I remember borrowing. Y'all didn't like it very much, but we could do it, and we practiced it enough. Y'all kind of got good at it. All right. For multiplying, y'all agree so far multiplying's been easier. If y'all agree with that, okay. It's fixing to get even easier. All right. Because all we're going to do if we have a whole number, you ready? It's going to be a little bit of magic here. I'm going to write 11, and I'm going to put my fraction bar up under it because I want to make 11 a fraction.
Oh, you put that on.
And nope. So to make 11 a fraction, on the bottom, I'm going to put a 1. All right? And instead of like our what crazy reactions, let's just chill for a minute. Let's think about it, okay? Let's use our brain. That fraction bar means division, correct? So if I read this problem, it says 11 divided by 1. What's 11 divided by 1? 11. What's 8 divided by 1? 8. What's 5 divided by 1? 5. What's 16 divided by 1? 16. So if I have a whole number, all I have to do is on the bottom put a 1 because it's going to be whatever's on top. All right? So I made that 11 over 1. Do I have to do anything to 5 and 8? Nope. We don't have to make anything match. We don't have to do anything at all there. All right, so I want to check. Do y'all see any numbers here that'll simplify? 11 and 8? 5 and 1? 5 and 8? All right, so nothing's going to simplify here, so I'm just going to multiply. We're ready to do the problem. So 11 times 5 is? 55. Fraction bar. 1 times 8 is?
8.
Okay, so I'm going to pause here. I'm going to ask a very important question. Listen carefully. Will this simplify? Remember, simplify means can I divide the top number and the bottom number by the same thing? Can y'all think of anything that'll go into 55 and also into 8?
No.
I can't. But can I leave 55 over 8? No. So I do need to change it. So my folks are thinking, but that's not good. You're right, it's not good. But we can't simplify it. What is it that I have to do to this number? Julia? We have to divide to make it a mixed number here. We're not dividing and simplifying. We're dividing and making it a mixed number. So if you want to, we can go over to the side. I'm going to write it to the side just so I remember what I'm doing. Remember, whatever is down goes at the door. So that leaves 55 to go in the house. How many times can 8 go into 55? Noah? 6 times. So 6 times 8 is?
48.
48. What is the difference? How far apart are 55 and 48? I can subtract, I can borrow and all of that, or I can just kind of think in my head, how far apart are 55 and 48? How many spaces? 7 spaces. So 55 minus 48 is 7. Okay, what am I doing with those numbers? Raise your hand if you can tell me. How am I going to write that answer using those numbers we just got? Raise your hand for me. Jessica? 6, and then 7 goes on top over 8. So remember, my whole number is on top. The leftovers we put up, and then 8 goes on the bottom. All right, 14. I'm sorry, number 4. Number 4, how am I going to make that 16 a fraction? Peyton? Put a 1 underneath. So 16 over 1 times 1 over 16. All right, again, I can multiply this out and then worry about it at the end. Or I can ask myself right now, can I simplify this problem? Can I simplify this problem? Raise your hand, please, guys. And we need to work on our hands because I keep getting some calls out of yeses, nos. Can I simplify this problem? Looking for a hand besides Jeremy or Peyton. Easton? No? I'm going to disagree with that. All right. Now, here's the thing. You could go straight across, multiply it. It's an easy problem whether you simplify or not. But this problem will simplify. Who can tell me what to do in order to simplify this problem? Frank?
Simplify
16 and 16, we can simplify them by 8, or we can even simplify them by
22.
Or we can simplify them by
4.
16. So we can simplify by 2, we can simplify by 4, we can simplify by 8, or we can simplify by 16. All right? I'm going to kind of show you, I'm going to show you what would happen. Let's say I chose, are you with me still? I'm going to say I chose to simplify by 8. So if I divide these both by 8, okay? There's a better way to do that, okay? All right, so 16 divided by 8 gives me 2 on the top, and then 16 divided by 8 gives me 2. But now I'm still going to have to simplify again, aren't I? So what can go into 2 and into 2? 2. 2. So I'm going to divide these by 2 now as well. So 2 divided by 2 is? And 2 divided by 2 is? 1. Okay. So now when I multiply, guys, on the top, what's left? I have 1 times 1 equals 1. And then on the bottom, I have 1 times 1 equals. So for the fraction, I have 1 over 1. Now, guys, remember we said that fraction bar is like division. What is 1 divided by 1? 1. All right? If I had worked out this problem without simplifying, I would have gotten 16 over 16. All right, so I'm going to do this is a little thought bubble here. All right, so just some things going through my head right now. If I have 16 over 16, guys, what is 16 divided by 16? 1. What if I had 8 over 8? What is 8 divided by 8? 1. What if I had 157 over 157? 1. Do y'all see how anything over itself is 1? So, tomorrow when we're checking our homework, and you say, but Miss Sawyer, I put 8 over 8. Is that simplified?
No.
So are we going to count that correct? No. It'll be marked wrong unless you make it a 1.
How many times did that go in there?
Exactly. All right. So with that said, the other thing, guys, we made this 11 over 1 for our work. Can I leave it as 11 over 1 in my answer? No, in my answer I would just write 11. You're going to have a lot of problems on your homework that are a whole number. If it has 1 on the bottom, write it as a whole number, okay? Let's look at the next one. 49 over 54 times 36 over 77. What can I do to work this problem out to make it easier? Because I don't want to do 49 times 36. That's a big number that I got to multiply. I got to go to the side. I want to see if I can simplify. Do y'all see anything in here that's going to simplify? Besides my 2 in the back. I'm not calling on y'all. All right. Anything on here that'll simplify? Remember, we can simplify by anything as long as top and bottom. Kelsey, what do you see? You see something. 36 and 54. What number would you like to simplify those with? 2. Those are even numbers, right? So I can divide them by 2. So 36 divided by 2 is going to give me 18. 54 divided by 2 is going to give me 27. Okay. All right. Do y'all see anything else on here that will simplify? Anything else that I can simplify? There is something else I can simplify. I'm going to give it away. What else can I simplify here? Christian, is that a hand? Okay. Perfect. So 49 and 77, I can divide those by 7. Do y'all agree? So 49 divided by 7 is 7. And 77 divided by 7 is 11. Okay. So we've simplified so far. It looks like we've simplified everything, but I can simplify more. Mary Webb, what do you see that I can still simplify? 27 and 18. What can I divide those by? We can divide them by 9. Or like Carrie said, we can divide them by 3. I'm going to go with 3. All right, so 18 divided by 3 is? 6. And 27 divided by 3 is? 9. Okay, again, I'm going to see, is there anything here that'll simplify? Julia, what do you think? 6 and 9. What can go into 6 and into 9? 3 again. So 6 divided by 3 is 2, and 9 divided by 3 is 3. Okay, So now, and this is starting to look kind of crazy, I'm just going to double check. Can 7 and 3 simplify?
No.
Can 7 and 11 simplify? No. So that's all the tops and bottoms there. Can 2 and 3 simplify? Can 2 and 11 simplify? So we should be good, all right? So we're going to do 7 times 2 on the top. I get 14. I'm going to write it underneath because I ran out of room. And then 3 times 11 gives me 33. Okay. Guys, the hardest thing on these is simplifying ahead of time. But if we'll get good at that, it's going to make the problem a little bit easier. Julia, Jakari, are you writing this down with me? Make sure you're writing this down with me, okay? All right. Number 6. All right. I know, y'all. I'm sorry. All right. Peyton. Yeah, so on this next one we have 7 eighths is fine. But I need that 4 to have a 1 on the bottom. So I'm going to write it as 4 over 1. Okay? We want to see, can we simplify anything on this problem? Can I simplify anything on this problem? Right? The 4 and the 8. What number can I divide 4 and 8 by? Carrie? 2. So 8 divided by 2 is? 4. And 4 divided by 2 is? 2. All right, I can still simplify on this problem. What else can I simplify here, Carrie? 4 and? 4 and 7 cannot. All right, but the 4 is important. The 4 and, Braden? The 2. So I'm going to simplify the 4 and the 2. What number can go into 4 and also into 2? Braden? 2. So I'm going to divide them by 2. 2 divided by 2 is? 1. And 4 divided by 2 is? Okay. So now on the top, 7 times 1. And 2 times 1 is 2. Alright, that will not simplify anymore, but can I leave it like that? So we're going to divide. How many times will 2 go into 7? 3 times. But that gives me 6, so how many is still left over? 1. And then we put 2 on the bottom. Okay? Alright. The next thing we have, number 7. There are 456 students in 6th grade. 2/3 of the 6th grade have above a C in math. How many students is that? All right. So when I'm looking at this problem, what does my brain start trying to tell me I need to do? When it says 2/3 of the student body, what does that sound like we're going to be doing? Dividing, right? Like I think like when I read this and I see 2/3 of something, I automatically start thinking about division. Have we divided today though? No. So here's the reason that our brain thinks that. 2/3 is a piece of something, right? And we know dividing makes what? Pieces, right? We said if you're breaking it up, use division. All right? When it says 2/3, we're thinking, oh, that means I'm breaking it up, so I'm dividing. The problem is that this problem is tricking us. It's tricking us. That's not what we need to do because fractions are funky. Okay? So when we see the word of, when I see the word of, what that really means is happening is that we need to multiply. So, for example, if I tell you that I have 6 classes of 28 students, what would y'all tell me to do? Multiply. 6 times 28, right? Because whole numbers are easy. But now when it says the same thing, 2/3 of the 6th grade, how many students are in the 6th grade? It says right here. 456. Guys, that sets up your problems. 2/3 of means to multiply times the 456. Do y'all see where my math problem came from? 2/3 times the 6th grade, which was 456 students. Okay, and I'm going to write that down in just a minute. Now, guys, of means to multiply if I'm talking about numbers. If I just say I have a bucket of strawberries, does of mean that I'm multiplying there? No, it just means that in my bucket there are strawberries. If I have a bucket of strawberries, of does not mean to multiply. It just means my bucket has strawberries in it. Okay? If I'm talking about a number of another number, multiply. Are y'all good with that? A number of another number means to multiply. Okay, so let's set that up. 2/3 was first, so I'm going to put 2 over 3 times, because of my of, and then 456, I'm going to put that over 1. All right. Now these numbers get a little big here. All right, these numbers get a little large. So what we might want to do is we might want to just go ahead and multiply. 2 times 456. So if I want to do that, I'm just going to go over to the side. 2 times 456. 2 times 6 is 12. Put my 2, carry my 1. 2 times 5 plus the 1. Carry my 1. 2 times 4 plus the 1. So on the top, 2 times 456 is 912. Over 3 times 1 is 3. Okay? Is that a good way to leave my answer? No. Now, 912, again, it's a big number. I might not know it, it'll simplify, but what I do know is I need to make it mixed. So I'm just going to do 3 at the door, 912 in the house. How many times will 3 go into 9? 3 times. 3 times 3 is 9. When I subtract, down the 1. How many times will 3 go into 1? None. So what do I have to put on top? A 0. All right. And then I'm going to bring down the 12. How many times will 3 go into 12? 4. 4 times 3 is 12. When I subtract, I get. So I get 304. Is there anything left over? So do I have a remainder or anything? No, so my answer here is 304. Now how am I going to write that? Peyton? Nope. Nope. Carlos? Jeremy? Braden? Christian? Peyton? Mary Webb? Y'all are making your answer more wrong. Easton? RJ? Jeremy?
304 and then 608.
Braden?
It's to me like it's the sentence, like the amount.
So what would that be?
I don't want to make that a sentence.
Gabriel?
304.
More than that. Más. Necesito más.
Okay. The wording was right. Yeah, no one more trying that.
Carrie?
There are 304 students.
There are 304 students. All right, and what happened with those students? That have above a C. That have above a C in math. Yes, Peyton? Okay, so y'all right, the answer was 304, and it was just 304, but it's a word problem. So you got to put some words in with that answer. I'm not going to tell you how many, I've made every single class mad today doing that. It's entertained me. All right, so make sure you have a sentence for the word problem. All right, I'm going to pass out our homework for us to look at real quick.